Good morning, boys and girls. We are jumping back to 3-1. Your multiplication properties. Kids always say, what the heck's a property? It's just a rule. It happens every time, so they like to point it out to you as a property. So an easy example would be the zero property of multiplication. And the zero property multiplication tells us whenever you multiply any number by zero, your answer, the product, is zero. 5 times 0, 0. 1 billion times 0, 0. 358,423 times 0, it's 0. That's all the zero property is. Really simple. So what they are going to do is they are going to, well, let me just continue. Another easy one, the identity property of multiplication. When you multiply any number by 1, the product keeps its identity, meaning it stays the exact same. You hear about like spies having a secret identity. That's like, oh, that's James Bond, but when he goes undercover, his name is George Smith. I don't know. It's a secret identity. Here we're saying that the identity of the number stays the same. It starts out a 5, it ends a 5. How does that happen? You have to multiply it by 1. 5 times 1 is 5. 5 times any other number in the world will no longer be 5 anymore. The only number that works for is 1. So, the zero property, anything times 0 is 0. The identity property, any number times 1 equals that same number. So then we get into the two that kids mix up all the time. We have the associative property of multiplication, and we have the commutative property of multiplication. All right, so here's how this works. When your parents commute, they are switching their place. They're going from being at home to driving to work. The commutative property, notice the root word there, commute, just says that the order of the numbers doesn't matter when you multiply. When you multiply 2 times 5, it's the same thing as 5 times 2. You can see that the numbers simply commuted. Here, the 2 was at the beginning, and now the 2 is at the end. The 5 was at the end, now it's at the beginning. They switched places, they commuted. So the commutative property of multiplication just says the order of the numbers doesn't matter. If 2 is at the front or at the end, and if 5 is at the end or at the front, it doesn't matter. When I multiply 2 times 5 or 5 times 2, they both equal 10. So if you have two numbers, you can multiply the numbers in any order that you want. All right, the associative property. Now the way I used to teach this is the associative property tells you that the grouping doesn't matter. So here the grouping, if you look at the numbers, I have 2, 5, and 3, and I have 2, 5, and 3. The order did not change. So since the order didn't change, it is not the commutative property of addition. What did change is they changed the parentheses around. Here, the parentheses are on 2 times 5. Here, the parentheses are on the last two digits, 5 times 3. What do parentheses mean? The parentheses mean multiply these first. So in this problem, I'm going to do 2 times 5 is 10, 10 times 3 is 30. Over here, same numbers, 2, 5, and 3, but here they're saying, ooh, multiply these two first. 5 times 3 is 15, 2 times 15 is 30. They both equal 30. And I used to teach kids, okay, your parents' associates, those are the people that they work with. It's their work group. Here they're being grouped. But then I figured out, you know what? Kids don't remember that stuff. They like remembering bad words. So if you think of the parentheses in a problem as a but, they kind of look like a but, right? You got like, I don't know, if like you're looking at someone, and there's a but and there's a but, right? And if you look at the first 3 letters of the associative property, there's another word for but. See, you're never going to forget this now. So if all they did was move the but around, you know it's the associative property of multiplication. All right? You will never forget it. But Don't tell anyone I told you that, because, yeah, bad. So, what these problems, are you done giggling yet? What these problems are going to look like is they're going to show you, oh, look, what property is this? Here I have 65, I multiplied it by 1, it equals 65. Well, that's really easy. It kept its identity. That's the identity property. Remember, anything times 1 equals that exact same number. So here's the 65, they multiplied it by 1, it equals 65. Here they took a number, they multiplied it by 0, and it equals 0. Well, that is the 0 property. Any number times 0 equals 0. Here, oh, super simple. Look at the numbers, 625, 625. They didn't change the order, they changed the but around. That must be the associative property of multiplication. See how this is all working? Number 2, 45 times 6 is equals 6 times 45. They changed the order around. The numbers commuted. That is the commutative property of addition. Here, they changed the order around. That is the commutative property of addition. The other way these problems are going to work out is they're going to say, fill in the missing box. All right, well, they took a number, they multiplied it by something, and it equaled the same number. Oh, that has to be 1. And what rule tells you that? The identity property of multiplication. Here they have some numbers. Ooh, see how they're trying to fool you? They're like, oh, look, parentheses, that looks like a but. But no, they didn't move the parentheses. They had some numbers, they multiplied it by something, and now it equals 0. Oh, this is a fancy way of showing you the 0 property of multiplication. You know that this missing number has to be 0. 24, 75 times something is the same thing as 42 times 75. Oh, well, they just did the commutative property and they left this number out. We can see right here that missing number is 42. So 42 is going to be your answer. And what property was it? It was the commutative property. The numbers just commuted or switched places. 21, oh, they're moving that but around. That's right, it's the associative property. Easy, see? Your brain likes swear words, what can I say? 23, 8 times blank times 4, 8 times 5 times 4. Oh, okay, well, figuring out the missing number is simple. It's 8, 5, and 4, and over here it's 8, 5, and 4. And then what did they do? They moved the but around. It's the associative property. 25, 9, 6, 4, 9, something 4. Oh, that's going to be the 6. They moved the but from the first, 9 times 6, over to the end, 6 times 4. That is the associative property. Alrighty, if you are the kid who likes to take notes, I will show you my notes right here. This is what I would have put on the whiteboard if you were in class. The commutative property of multiplication, it simply means order doesn't matter. Here's an example of it. The numbers commuted just like your parents commuting to work. They switched their location around. 3 came first, now the 3 is coming last. The identity property, anything times 1 equals that same thing. 7 times 1 is 7, 46 times 1 is 46. The number keeps its identity. That's the way to think about it so you don't forget it. The 0 property, anything times 0 equals 0. That's what the rule tells you. So some examples, 18 times 0 is 0, 3 times 0 is 0. And then finally we have the associative property, which is grouping doesn't matter. Here I group the 3 and the 2. Oh, so first of all, the 3, 2, 4, 3, 2, 4, that hasn't changed. I changed the grouping from the 3 and the 2 to the 2 and the 4. If you think of this like a but, and then if you look at the first 3 letters, you know it's the associative property. And that's the weird way that your brain will never, ever, 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 ever forget this. In fact, when you guys are parents and your kid brings this home and your kid says, I don't get the associative property, you're like, oh, dude, piece of cake, you just moved the but. And your kid's going to go like, what? You're like, yeah, I had this teacher, Mr. Stanos, he is totally cool. He taught me that. You move the but around, it's the associative property, piece of cake. Yeah, you will never forget it, literally. All right, hope you guys had a good one. I will kind of pause on that. If you want to take notes, that is up to you. Some people are note takers, some people are not. And you need your answers for today. 3-1. So sometimes they want the rule, sometimes they want the missing number. There is your reteach. And here is your practice page. Looks a little blurry. All right. Good luck. Any questions, let me know. I'll see you.